Hello my dear students, welcome to Byju's Exam Prep. In this Sunday Ka Funda, today we'll be talking about a very interesting concept of Tesla wall. Now before understanding the concept of Tesla wall, let me take a very small example. Let us suppose there is a nozzle, right, and it is a unidirectional. That means if a fluid is trying to enter from this side, it can easily exit out from here, but the fluid when it is taking the enter from the opposite side, it won't be able to come out from this. This is a unidirectional. Okay, so multiple number of unidirection you might have seen in your practical appliances, like in your motor also we are having this kind of arrangement. So definitely there is always a movable part, okay, which is trying to block the fluid flow. But Tesla has basically given a very awesome physics concept in which without having a moving element we can build a unidirectional flow wall. So let us talk about more in this particular video in the second. So welcome back students, let's talk more about the concept behind the Tesla wall. Now as we have already seen from that experimentation also, or from that discussion also, that we have seen multiple applications where the fluid is trying to flow in one direction only, and there is a movable part which is trying to obstruct the fluid flow. That means if the fluid tries to reverse the direction, if it is entering from the opposite side, the fluid won't be able to complete its motion. The wall will be basically obstructing the fluid flow. But the thing is, whenever we are having this kind of design arrangement, and if you're having a movable part being associated, the durability aspects of that design will be slightly less, because it is always being associated with the movable part. And if there is some defect or failure in that movable part, then the entire concept of unidirectional flow will be altered, right? So उससे क्या होगा, आपका जो जिस चीज के लिए that unidirectional wall was designed, it won't be fulfilling. Okay, that means the fluid will be able to move very easily in both the direction. So if you try to eliminate that movable part, and if you are having a design such a way that the fluid is trying to move in one direction only, even if I am not having a movable part, that will be the best design in a we can say in the field of engineering, right? So Nikola Tesla actually has given his design, and this was so mind-blowing that you will be able to understand from basic concept of fluid mechanics is being used to design this Tesla wall, which is given by Nikola Tesla. So for understanding this, how the design is actually working, for that we'll be taking some basic examples to have more clarity. Let us suppose there is a wall, and on the periphery, on the circumference, we are having a uneven shape like this, and it is identical from both the side. Okay, it is identical from both the side. So when the fluid is trying to enter from left to right or from right to left, in both the scenario, the fluid is being it is basically facing the same resistance. So it is not a unidirectional flow, because if the fluid is changing the direction, still the fluid is able to move in the same way and same resistance being offered. So let us try to improve or alter the design so that we can say the fluid will be able to move only in one direction. Let us suppose in this particular scenario, I've taken a design like this. So when the fluid is trying to enter from the left hand side and the fluid is trying to enter the right hand side, in both the scenarios, the fluid will be having a different flow rate. Reason being, on the one side, we are having a diverging nature. If it is trying to enter from the left hand side, it is having a diverging nature, and if you're trying to enter from the right hand side, it is a converging nature, right? And we always know that when the fluid is trying to converge itself, its velocity is going to increase. Okay, and what will happen? Your pressure is going to decrease. So it's quite suitable for a smooth flow, right? But on the other hand, if you're having a diverging flow, what happens? The velocity is going to drop down, the pressure is going to increase. So when the fluid is moving ahead, so there are chances of adverse pressure effects, due to which the fluid will be moving in the opposite direction. There is a high chances that in a diverging flow, after a certain distance, the fluid will be coming back. We will be having a back flow, because of the pressure increment is very high, right? So if you try to visualize, when this particular fluid is trying to enter from this end, okay, let us suppose it is trying to enter from the right end, okay, it will be easily able to move because there is very less restriction, or because it's a we can say converging in nature. But on the other hand, if you talk about a diverging nature, when it tries to move, right, when it tries to move in this diverging nature, what happens is the fluid pressure is gonna rise. ठीक है, pressure आपका बढ़ेगा, right? Due to which there will be a point where the fluid will be trying to move in a backward direction. Okay, due to this adverse increasing pressure, the fluid particles will try to move in the opposite direction, which try to hinder the flow. तो उससे क्या होगा? The resistance of the flow will be increasing. But on the other hand, if you're having converging nature, बहुत बढ़िया है, it's very easy. Your pressure is gonna decrease, and ultimately it's basically making us a very smooth flow, and the fluid will be able to move in a unidirectional way. Right, won't be having a backflow at any point of time. But in case में, whenever I'm talking about diverging flow, after certain distance, there's a high possibility of creating a vortex. ठीक है, आपका vortices बनने के chances there are high chances of creating a vortex flow. Okay, fine. Vortices बनने के there are high chances. Let us talk about a simple design. Like if I talk about the Tesla design, this was the original design being given by Nikola Tesla. Now in this case, if you try to magnify, right, so the design is quite simple. When the fluid is trying to move in from this direction, okay, it will be having two pathway. This pathway is basically the majority of the fluid particle will be moving in this particular direction because there is less obstruction. Okay, so this kind of stream we call it as primary stream. Okay, इसको हम बोलते हैं primary stream, right? And the fluid which is trying to move from the upper pathway, that is called as secondary stream. Okay, तो ये converge होगा and ultimately it will be able to move very easily. There is no obstruction happening. But let us suppose we are moving from the opposite side. Opposite side, if I try to move, what will happen when the fluid enters from this side? Okay, there are two possibilities. There will be small amount of fluid will be entering from this secondary pathway. Secondary, this is the primary pathway. But there is a complete 180-degree turn. This is a complete 180-degree turn. It's like two अगर आप दो पाइप लेंगे, two water pipes, if you are trying to place it just opposite to each other, there will be huge pressure drop. Okay, they will be colliding and the energy is gonna decrease, and ultimately there will be huge losses you will be able to visualize. और यहाँ पे there are high chances to create a vortex. ठीक है, vortex बनने का या vorticity या vortices बनने का there are high probability. So imagine a situation that at every interface the vortex is being basically made, and due to this complete 180 there's a huge drop in energy. Okay, पिछले वाले में क्या था, when it was entering from this side there were no chances of vortex flow. It was easily able to move. There are no chances of vortex flow. But in case of opposite sense, then the Tesla basically given this arrangement, and by using this simple fundamental concept of fluid mechanics, he is able to create a unidirectional wall only by changing the design. Only by knowing the concept of fluid mechanics, he is able to understand this logic, and he is basically trying to make a unidirectional wall without having a movable part, and that's the best thing for any design perspective. Okay, fine. So if I try to attack this wall, this particular Nikola wall, right, the previous way, in the first case what happened, I'm going for a unidirectional, and if you can see the flow rate is very high. But when you try to turn, the flow rate becomes drastically decreased and the pressure drop is very high. Okay, and without having this movable part, we are able to design this particular concept of unidirectional wall without having a movable part. And this concept or this design is being implemented in your pulse jet engine also. In pulse jet engine, we are trying to we are basically implementing this wall in order to have the better efficiency. Okay, so this is all about the concept of Nikola's Tesla's wall. So I hope you all enjoyed. Do share this video to all of your friends. For more such awesome content, do connect with our Byju's exam prep. Thank you guys. Bye bye. Take care, stay safe, and enjoy your preparation with Byju's exam prep. Thank you.